Okay, so now that we know how to identify a p-series, now we're going to decide if it converges or diverges. So one of the things that we want to do with p-series is that p-series converge and diverge kind of like a geometric series does. If it meets a certain requirement, then it works. If it doesn't, then it doesn't. So a p-series converges if p is greater than 1. It diverges when p is between 0 and 1 or equal to 1. Because p is always positive, we know that we're not going to have to worry about these negative values for p. So one thing to also note is that this doesn't actually determine if it converges. It determines if it converges or diverges. It doesn't actually determine the sum. So we're going to decide if the following are converging or diverging. And we need to decide if they're p-series. So if we look at this first one. So this is the summation from k equals 1 to infinity of 1 divided by the 4th root of k cubed. So we want to go ahead and rewrite it. If I remember my exponent rules that we use when we use power rule, p-series, we are going to change the 4th root of k cubed to the 3/4 power. What this tells me is that we have a variable in the denominator, we have a power on that variable, so this is a p-series, and p is equal to 3/4. 3/4 is less than or equal to 1, and because it is less than or equal to 1, it diverges. Okay, we have the summation from n equals 2 to infinity of n to the negative pi thirds power. So we are going to go ahead and change this around. So we have the summation from n equals 2 to infinity of 1 over n to the pi over 3 power. It is a variable to a power, so this is a p-series where p is equal to pi over 3. Well, pi is 3.1415, which is bigger than 3. So I have something a little bit bigger than 3 divided by 3, so this is going to be bigger than 1. So it converges. And our last one here, we have the summation from k equals 1 to infinity of k to the power of 1 minus pi. So we have a couple different options on how we might approach this. What I'm going to do is I'm going to go ahead and do what we've been doing, which is just move it to the denominator. So we have 1 over k to the negative 1 minus pi power. So looking at this right now, we have a negative exponent, which is not what we want for a p-series. So we're going to go ahead and simplify this exponent. Summation from k equals 1 to infinity of 1 over k. So we have negative 1 plus pi. So the summation from k equals 1 to infinity of 1 over k to the pi minus 1 power. So the good news is that pi is bigger than 1, so we know that that is going to be a positive power. So this is a p-series. P is going to equal pi minus 1. Pi minus 1, 3.14 minus 1 is still bigger than 1, so this converges. A lot of the times when we're doing these different series, we can't find the actual sum. We're just deciding if it converges or diverges. So we hope it's something like this, where it's a p-series, and it's really easy to kind of just go, oh, p is equal to this. This is what happens. So p-series are kind of one of our ones like geometric series that we kind of hope to see.